Hey, this is Jason Molesky. In this example, let's construct a confidence interval for the difference between two population means. The Wade Tract Preserve in Georgia is an old-growth forest of longleaf pines that has survived in a relatively undisturbed state for hundreds of years. One question of interest to foresters who study the area is, how do the sizes of longleaf pine trees in the northern and southern halves of the forest compare? To find out, researchers took random samples of 30 trees from each half and measured the diameter at breast height, dBH, in centimeters. Comparative box plots of the data and summary statistics for Minitab are shown below. So here we have our box and whisker plot for the northern region and the box plot for the southern region. And we also have our descriptive statistics showing random samples of size 30 for the north and south with their respective means and standard deviations. Based on the graph and numerical summaries, write a few sentences comparing the sizes of longleaf pine trees in the two halves of the forest. Well, the distribution of dBH measurements in the northern sample is skewed to the right, as evidenced by the box plot, while the distribution of dBH measurements in the southern sample is skewed to the left. It appears that trees in the southern half of the forest have larger diameters. The mean and median dBH for the southern sample are both much larger than the corresponding measures of center for the northern sample. Further, the box plots show that more than 75% of the southern trees have diameters that are above the northern sample's median. There's more variability in the diameters of the northern longleaf pines, as we can see from the larger range, IQR, and standard deviation for this sample, and no outliers are present in either sample. Now in this example, notice that we were explicit in comparing the northern portion to the southern portion for every characteristic that we talked about. If you're asked to compare two different distributions on the AP Stats exam, make sure you use explicit words linking one distribution to the other, saying one is greater than or less than, one is more skewed or less skewed, and so on. Don't just list out characteristics for each different distribution. Now let's construct and interpret a 90% confidence interval for the difference in the mean dBH of longleaf pines in the northern and southern halves of the Wade Tract Preserve. Our parameters of interest are mu1, the true mean dBH of all trees in the southern half, and mu2, the true mean dBH of all trees in the northern half of the forest. We want to estimate the difference mu1 minus mu2 at a 90% confidence level. Well, if our conditions are met, we'll construct a two-sample t-interval for the difference in means. We note that the data came from independent random samples of 30 trees each from the northern and southern halves of the forest, so our random condition is met. Because we're sampling without replacement, we have to check our 10% condition. We need at least 300 trees in each half of the forest, and I'd say that's pretty safe to assume. And the box plots here give us reason to believe that the population distributions of dBH measurements may not be normal due to the skewness in the box plots. However, because both sample sizes are at least 30, we're safe using t procedures. We'll use the more conservative degrees of freedom, the smaller of n1 minus 1 and n2 minus 1, or in this case 29. For a 90% confidence level, the critical value from table B for 29 degrees of freedom would be t star equals 1.699. So, a 90% confidence interval for the difference in our means will be the difference in the sample means, plus and minus our critical t times the standard error of the difference of those means. 34.53 minus 23.70 from our output, plus or minus 1.699 times the standard error. We have 10.83 plus and minus 7 for a confidence interval from 3.83 to 17.83. Now the calculator's two-sample t-interval gives a slightly different range. In this case we use degrees of freedom 55.728, and you'll see we have slightly different values for our minimum and maximum, however fairly close. So we can state we're 90% confident that the interval from 3.9362 to 17.724 centimeters captures the difference in the actual mean dBH of the southern trees and the actual mean dBH of the northern trees. For some additional practice in constructing and interpreting a confidence interval for the difference of population means, try exercise 37.